Okay, we're gonna do possible rational real roots, and then we're gonna do division using possible rational real roots. So you don't get this part, so don't look at this. This is just to make sure that something nice happens for you. Okay, so this is what we started with. Okay, so when we start with something like this, we're gonna call this P and Q. And the way that we find the rational real roots is all of the factors of Q over all the factors of P. And when I do all the factors, I need to make sure that I do a positive and a negative. So factors of 6, I have 1, 2, 3, and 6. And each of those are going to be over all of the factors of 6, which are 1, 2, 3, and 6. So I have 1 over 1, which is 1, positive and negative. I have 1 over 2, which is 1/2, positive and negative. I have 1 over 3, which is 1/3, positive and negative. I have 1 over 6, which is 1/6, positive and negative. I have 2 over 1, which is 2, positive and negative. 2 over 2, which is 1, I already did that. 2 over 3, which is 2/3, positive and negative. 2 over 6, which is 1/3, I already have that. 3 over 1, which is 3, positive and negative. 3 over 2, which is 3 over 2, positive and negative. 3 over 6, which is, 3 over 3, which is 1, already have that. 3 over 6, which is 1/2, already have that. 6 over 1, which is 6, positive and negative. 6 over 2, which is 3, already have that. 6 over 3, which is 2, already have that. 6 over 6, which is 1, already have that. So these are my possible rational real roots. To find out the actual factors, I'm going to use synthetic division to divide these out. So when I do synthetic division, I first make sure that it's in standard form, which it is. I make sure if I'm missing any exponents, which I'm not, I have x to the 4, x to the 3, x to the 2, x to the 1, x to the 0. And I just list the coefficients. So 6, 37, 72, 47, and 6. In this box, I'm going to put one of my possible rational real roots, and I'm going to try it out and see if it gives me a 0 right here as the remainder. I can't have a remainder if it's a root. So because these are all positive, I'm only going to try the negative values. So I'm going to try -1. The first number always comes down. I multiply. I add these. 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 So it gave me 0 remainder, which means that this is one of the solutions, which means one of my roots. No, this is one of my roots, which means one of my factors is x plus 1. I know that because whatever zeroes this out. So now I'm going to go from here. In order to check if there's multiplicity, I'm always going to check the same number again. First number comes down, and I multiply, add them together, and I multiply, add them together, multiply, and it gave me a remainder, so that is not another root. So I'm going to cancel that out. I'm going to stick with these numbers. I'm going to try another one. I'm going to try all of my integers first. So I'm going to try -2 now. 6 comes down, and I multiply. Add these together, and I multiply. 8. Multiply. So that worked, which means I also have a factor of x plus 2. Okay, so I started with x to the 4, which means this is now x to the 3, which means this is now x squared. When I get to a quadratic, I'm going to put it back in because it's going to be faster for me to factor this out than to try to go the other way. So to factor this out, I need two numbers that multiply together to 18 and add to 9, which is 18 and 1. Because I have a value that is not 1, it goes over that value. And I simplify. This can't be simplified, so the denominator comes up. And these are also factors. So these factors plus the 2 that I already got, and that's factored out. So that's what we're going to do today.